Okay, so first and foremost, worksheets, or sorry, homework. If you want to make fixes, you can do that. Just turn in the front and back basket. Just make fixes on there. The page 18 that's due today. If you want to wait till the end of class and I'll answer some questions, we can do that. The goal today is to take a few notes, intro section, super light notes today, and then once we're done with the light notes, then I'll answer questions on homework. You can take fixes and whoever you need. Make sense? Remember, it's a light intro day. No homework, nothing like that today. Just intro the topic. Maybe you don't get it fully understood yet, but intro what we're going into, and then tomorrow we'll hit it more in depth. Okay, so let's start with this. Here's our topic here. We're talking about midpoint and distance. Obviously, we're graphing a lot today, so we're going to be talking about how to draw graphs. So this is kind of a review of Algebra 1 material. So hopefully you get familiar with that again. For some of you, it's been a long time since you did Algebra 1. You probably forgot some little things here and there. So we're going to fill you in. But big two things today is to talk about. Number one, we got to talk about midpoint. So I want you to know that word. I think we used that word, last Friday? Talked about it a little bit. And then the second word I want to talk about today is distance. Because they are two very, very different things. Okay? All right, let's do the definitions first. What do we know about midpoint? What does midpoint mean?
Halfway.
Say it?
Halfway.
It's the halfway point. It's like, you nailed it, right? It's that point directly in the center. The point at the center, the exact center of a segment. It's the halfway point, right? It's the exact middle. So that's why they literally took the word middle and point and made it a new word, midpoint. So let me draw. So we have a segment. Let's call this A to B. And let's call point C here. That's my midpoint. Now, how do you know? Well, number one, it could tell you in the instructions, like up above the problem. C is the midpoint. So that's direct center, direct middle. Or, number two, they could do this. And this is something I think we talked about Friday, but I don't know how in-depth we got. They could put these markers. What do those markers mean? Those little hash marks mean.
Oh, it's perfectly split into half.
Yeah, they're exactly the same size. What else? There's a keyword I'm looking for. It starts with the letter C.
Congruent.
What's it?
Congruent.
Congruent, yeah. They're congruent to each other. These sticks are exactly the same size because those little marks are the congruent markers. So if you ever see those in your book, it means those sticks are the same size when they put those little hash marks on. So A to C and C to B. So again, C is the halfway point. It's the perfect middle. So they could either give you the two markers to show you that's the middle, or they could just tell you just flat out, C is the midpoint. Okay, now, why we're doing this. If I gave you a number line, so let's draw this number line here. 1, 2, 3, 0, 1, 2, 3. Okay, so the 0 in the middle on a number line is called the origin, just so if I ever use that word, you understand. So 0 is the origin, then going to the right is positive numbers, to the left is negative. One of the things we have to be able to do is if I give you two dots on this graph, could you find the midpoint of them? So for instance, if I told you -3 and let's say 1. Let's call this B and let's call this A. Could we find the perfect midpoint between both of them? What do you think? What's the midpoint between -3 and 1? Up there. Did I land on a nice number? Is it a decimal? What do you think? Where's the perfect middle? -1. Most people have a spatial acuity that you could just look at the picture and go, it's about there, right? The human brain is super exact. Like if you think like that looks like the middle, you're probably insanely close to it. Like the human brain can pick that out. -1 is a percent, right? This would be the actual midpoint. Okay, so we call that point M if you want to call it that, right? That's the perfect middle. Now, here's the thing. maybe you don't have that. Maybe you look at it and like, kind of look like -1, but I wasn't sure. We have a formula. And that's what we're going to look at today. There's actually formulas that we can use for formulae. Bless you, whoever sneezed. We can use a formula that will actually tell you exactly what the number would be for the middle. And so that's the nice thing. Like, we don't need to guess. We actually have like a set thing, but it only works for a number line. So we can find that middle. Okay, do we understand what midpoint means though? Like in terms of like drawings. Okay, let's go to the second one. Distance. The word distance. It is the length between objects. Right, it's that raw number, that digit from one object to another object, right? Distance is easy. If I said, find the distance from A to B, the raw distance, one dot to another dot. Most people could go up there and count their fingers. It's literally the spaces between hash marks. So, to go from A to B, you just count these spaces. So that's 1, 2, 3, 4. It is literally the distance from A to B is 4 spaces long. 4 individual spaces. Not how many hash marks, but spaces between them that I would actually cover. And again, leaving the bar off of it means I want the raw distance from one to the other. Okay, do we understand the difference between midpoint and distance? Okay, now let's talk about the formulas now. The actual formulas that we can use to find these. Let's talk about the first one. Let's do midpoint first. So here's what I like you to do. All right, draw your number line, go from -3 up to 3, put it in your notes, and let's start with A at -3, and we'll count up. So we'll go B, C, D, E, and we'll just keep going. B, C, D, E, F, and G. So draw this picture in your notes. A, B, C, D, E, F, G, so that's going from -3 up to +3. And it's a number line. So try to make them equally spaced and all that good stuff. So what we're going to do is we're going to talk about the formula itself. So you don't have to guess anymore. Some people don't like guessing. They just want to know how do I calculate it. They're just very analytical. They want to type it in the calculator, hit enter. So let's talk about how to find midpoint. So midpoint, the formula, right? And we're going to do this for a number line. Now, Brian, what did you say earlier about, what do you know about midpoint? It's the center. Best way you can put it, right? It's the direct center. It's the best way I can put it, other than saying it's direct center because it's very visual. It's the average. It's the middle number in the middle of them, right? It's the average. So it's like you're going bowling, and you're going to bowl a bunch of games. The average is the middle number. It's that central number between your whole list of scores. So what I always say is, like, if you're going to find midpoint, here's the formula. You take whatever your two scores are, x1 and x2. Those are my two scores. You add them together and divide by 2. That's how you find an average. Right? It's your average in scores. It's the middle score between the two. That's how you find midpoint. So, let's say I want to find the midpoint from A to E. A to E, the midpoint. It's the same math I just showed you a little bit ago. But you take the coordinates. What is the coordinate for letter A? -3. Okay, there's my first coordinate I had. Okay, what's the coordinate for E, the endpoint? 1. So you add the two together, the two coordinates you got. So A and E, my two endpoints, A and E. You add them together and then you divide it by 2. And this should give you the midpoint every single time. So what's -3 plus 1? -2. 2, divide by 2. Boom. And that was the dot we said was the middle. We said this was the dot between. It was point C or -1. That was the midpoint. Does that make sense how to use the formula? It's an average. You add the two endpoints, divide by 2. Okay, questions at all about that? Perfect. All right, let's go to distance now. To find distance from one to the other. Okay, other than counting with your fingers. Because most people can do most of this counting with your fingers. Now let's find distance. Okay. All right. Distance, the formula on a number line. What you do is you take the two endpoints. Let's say I want to find a distance from A to E. A to E. I want to know what that distance is, raw distance. So, what you do is you take the two coordinates. I don't care the order you take them. X1 and X2. Wherever the two coordinates are, A and E. You're going to subtract them now. And then put them in absolute value bars. That's how you find a raw distance. That's the formula that they use. What does absolute value bars do?
Makes anything a negative positive.
It makes everything positive. Doesn't matter. It's not an opposite. It's not making it like, if you have a positive number, it's not making it negative. It's taking everything and always making it a positive number. What I always say an absolute value does is how your smartwatch works, like an Apple Watch or a Fitbit. If you start walking forwards or backwards, it's keeping track of every step you take. Doesn't matter if you went forward or backwards. It just marks the distance you're covering, and it's adding it up. It's doing this. It's taking your beginning, your endpoint, subtracting them, figuring out all the steps you took in between. That's what, it's constantly doing that, and adding it to its total. So, x1 and x2. Those are my two coordinates. I don't care the order. In fact, I'm going to prove that it doesn't matter the order that you tell me. So, A and E, give me the endpoint for A. What is endpoint? -3. We're going to subtract the endpoint for E. What's E? 1. You're going to subtract them like that. This will give you the raw distance between the two. What's -3 minus 1 more? -4. And the absolute value of -4 is 4, right? It's the positive number. So that's the distance. Well, duh, you can just count with your fingers, right? 1, 2, 3, 4. There's 4 spaces between A and E. Now, it didn't matter the order. So if you were the person that maybe you thought you're going to put E first and A second, so you're going to do it a completely different way. So you saw it as, okay, I'm going to start with the number 1, and I'm going to subtract, because you always have to subtract the other number. The other number was -3. You always subtract the two numbers. I don't care the order you put them, but you have to subtract the two. So I have 1 and -3 is subtracting. What happens to two negative signs? Yeah, these cancel each other out, right? Inside the radical, they cancel each other out, or inside the absolute value bars. And so this adds together to make 4, and what's the absolute value of 4? 4 still. It doesn't matter the order you subtract. It will always give you the raw distance between them. That's the beauty of doing absolute value bars. Okay, questions with that? Well, you're probably thinking, Ward, I didn't need the formulas. Most people can count with their fingers. I do this because if you had numbers that were really far away from each other, I don't want to count. Or if you had decimals, this gives you a formula you just type in your calculator and kind of do it. Whatever the two numbers are, always subtract. Okay, questions? Okay, all right. Last thing I want to cover here. This is taking like 2 to 3 minutes. Okay, here we go. Boom. Put your name on these. Do not throw these away. These are for your notes only. I do not want to see these laying on the floor when you leave.
Alec, would you like the paper?
All right. First, you got a piece of graphic.
I hope it doesn't do that.
Everyone's got one? Okay, put your name on it. Let me explain. What we're doing now is we're going to talk about distance and midpoint, but we have to be a little more difficult, I should say. And this is going to remind you of what we did in Algebra 1 class. Hopefully it's a refresher. I don't know. Some people have seen it, some people haven't. So, okay, that's what you have in front of you, right? You just have a ton of it. This paper that I gave you is just for your notes. We're going to always put our notes on this. You'll keep it, just keep it in your notes. Just use it as a bookmark. That's kind of the easiest way that I would do it. Does everyone have one that the X and Y are labeled, correct? Now I know some people, my brothers, some people like to turn their paper on its side. If you're going to turn it on its side, you have to relabel X and Y. So Y should be on the top, X should be on the side when you're looking at it. So they're always that way. Now, here's the thing. The name of this thing. It's Cartesian coordinate plane. Coordinate. Coordinate plane. There we go. Can't spell. Cartesian coordinate plane. It is a 15th century math concept. 15th century. That's the 1400s. Wrap your head around it. 1400s this thing was created. You're like, Lord, why do we do it? Like, it's made by a French mathematician, René Descartes. This concept, this thing you're looking at, is used in every smartphone you have. In every Chromebook, every MacBook, every computer screen. They still use this system to run the pixels on the screen. So when you touch your smartphone to open up Snapchat or Instagram or whatever you're using, it's doing this system in the background so it knows what pixel you touched, and that's the app that opens. It's the craziest thing in the world. 15th century. And they still use it. GPS coordinates, right? Global positioning. They still use this system. It just wraps it around the globe so it knows exactly where you're standing. It's the craziest thing in the world that this old of a concept we still use for modern technology. Okay, so coordinate plane. What most people don't understand is that there's certain things on it. We have a y-axis and an x-axis. Those are labeled, correct, for you? Y is going up and down, x is going horizontal, correct? Okay, there is an origin to this thing. Where is the origin at? Where's the origin?
0, 0.
Yeah, center, right? It's at the center, it's 0, 0. This is the origin. Here's how you think of a coordinate plane. It is two number lines overlapping. This looks complicated until you just think about it. It's one number line going this way. It's another number line going this way. And all they did to make this graph was extend the lines. So where the 1, 1 line is, all they did was extend it up and down, right and left, and it makes the whole grid system. That's all they did. So now it makes more sense. It's just two number lines overlapping. That's why I tried to darken them in. They are darker, correct? Someone? It's hard to see, but they are darker. Now, there are certain things you need to know so that we all get the same answers as everyone else. There's 4 quadrants. 4 quadrants. Okay, 4 quadrants. They're Roman numerals. Where is number 1? Where's quadrant 1? What spot? Where's it going to be found? Where you got? Top left? Up here? Any questions, qualms about that? Anyone else think differently? It's not there.
Just the top right.
It's top right. It's top right. It's right here. This quadrant number 1. Put it in Roman numerals on your graph. You can we're just picking that first graph we're going to look at. Quadrant 1 is in the upper right. Close. Very close. Now, where's 2? Upper left. 2 is in the upper left now. It goes counterclockwise. And 3 and 4, and yes, you have to Roman numerals. We don't use numbers because numbers look like coordinates. We have to use Roman numerals. Now, there is a reason why it goes counterclockwise, and we're gonna look at that later this week. We're not gonna look at that today, why it goes 1, 2, 3, 4 counterclockwise. Okay, so to get to any spot on this graph, you have to know a simple item. You have to know a coordinate. Another name for a coordinate is called an ordered pair. That's another word for it. Ordered pair. Why do they call them ordered pairs? What's a pair?
2.
2 numbers. Pairs 2. What does ordered mean? Say it again. They're in order. Certain type of order, alphabetical. They're literally in alphabetical order. X first, Y second, every single time. Now, the best way, the easiest way I can explain this to you, to find any coordinate on here, any ordered pair, is imagine you're walking into a hotel lobby. This is the lobby of your hotel. There is a ton of elevators in front of you. You have the 0 elevator, you have 1, 2, 3, then you have -1, -2, -3. They're all numbered. You have to pick the elevator that you want to go in first, then you can go up and down in it. That's the easiest way I can explain it visually. That way you never get it wrong. So if I said I want you to go to 2, 6, what do I have to do first?
Up and over.
Pick the elevator, then go to the 6th floor, right? I'm picking the second elevator, and I'm going 6th floor, that's like here. 1, 2, 3, 4, 5, 6. That's 2, 6. You would not believe how many people still get that wrong. If I said I want you to go to 0, -4, where are you going?
Just going down.
Going down 4 spots, right? You're picking the 0 elevator, going down to the -4th floor of the basement. 0, -4. Pick the elevator, go down or up in it. Does that make sense? You'll not get it wrong if you think of it in terms like that. That way everyone's getting the right dots in the right spots. All right, I'd like you to draw those 2 dots. Put those on your graph if you haven't already. Those are gonna be our 2 we're gonna use the next couple times. Okay, my goal tomorrow, obviously today was an intro day, right? The goal tomorrow is to talk about how to find midpoint on this picture and how to find distance on this picture. It is not easy. It gets complicated, the formulas are weird looking. That's the part we're gonna look at tomorrow. Because I can guess where I think the middle is. You know, if imagine there's a line connecting those 2 dots, right? Imagine there's a line. I can kind of visualize the middle of the line is about right there-ish, that ballpark. But to find the perfect center, to find the midpoint of that line, takes a formula. Some people are really good at counting by hand, but I would suggest a formula. Okay, does everyone understand what we're doing tomorrow? And then we'll figure out raw distance. All right, we're done for the day. We have about 13, 14 minutes here. You can ask questions on your homework. If you have any, don't be afraid. Fire them out there. We'll talk about them, we'll go over them. If you're done with the homework, you put it in the front and back basket. Just don't let me find those graph papers on the floor. We're gonna need those next couple days for notes.